Good morning, children. How are you all? I hope you are well. Nowadays, you are very busy with your classwork, homework, and also online classes. Yes, children. Are you studying your classwork note? Or are you studying your book? Are you sending the homework, children? Whatever we are giving, you must do. Okay? And also, you eat healthy food. It protects you. When we are taking healthy food, that leads to give you healthy. Yes or no? They make you to give strength. Yes or no? So we must take healthy food. We must take healthy food items. Okay, children? Okay. Listen, everybody. We have completed 2 lessons and we started 3rd lesson. But 3rd lesson not yet completed. The structure of atom. Structure of the atom. We have seen early theories of matter. Indian sage who developed atomic theory 2600 years ago. Then Acharya Kannada, Dalton's atomic theory, subatomic particles, discovery of fundamental particles, properties of electrons, discovery of proton, properties of proton, Thomson's atom model, discovery of nucleus, Rutherford's atom model, discovery of neutron, Boyer's atom model. Then we have studied atomic number, mass number, atomic mass, what are isotopes, then some elements and their isotopes, then electronic configuration of elements with atomic number 1 to 20, valence shell, valence electron, valency, positive and negative valency, then some common radicals. We have seen these all. Now listen, in this class we study about radioactivity, kadiriyakathanmai. Okay, we will study about radioactivity. What do you see in the picture? Antoine Henry Becquerel. Antoine Henry Becquerel. Listen, I explain about him. In 1896, Antoine Henry Becquerel discovered the phenomenon of radioactivity. He discovered the phenomenon of radioactivity. Kadiriyakathanmai. Okay, radioactivity. He found out that uranium salt, which was kept along with a photographic plate, that plate covered with black paper, so they emitted some kind of invisible rays. They emitted some kinds of invisible, கண்ணுக்கு தெரியாத கதிர்களை அவைகள் என்ன செய்கிறது, வெளிவிடுகின்றன. So these rays affected the photograph plate. That invisible rays, invisible rays affecting the photograph plate. So that invisible ray name is called radioactive rays. Okay. Antoine Henry Becquerel, he was the great man. He discovered the phenomenon of radioactivity. Okay, he found out the uranium salt. That uranium, it is one of the salt. It was kept along with a photographic plate. That one covered with black paper. So they emitted some invisible rays. So that invisible rays affected the photograph plate. So that, what is that name of the invisible ray? That is radioactive rays. Radioactive rays. Okay, children? Listen, everybody. Radioactivity is the phenomenon of spontaneous emission of radiation, kadirveechu. Radiation, kadirveechu, is the phenomenon of spontaneous emission of radiation by certain elements. Uranium, radium, they are elements. Okay, we are giving some examples. Uranium, radium. So the elements emitting such radiation, kadirveechugalai velidid, so they are called radioactive elements. These elements emitting such radiation, that's why radioactive elements. What are called radioactive elements? Certain elements emitting such radiation, that is called radioactive elements. Okay. Radioactive decay is the process by which an unstable atomic nucleus loses energy by radiation. Radioactive decay is the process by which an unstable atomic nucleus loses energy by radiation. A material containing unstable nuclei is considered radioactive. 3 of the most common types of decay, alpha decay, beta decay and gamma decay, all of which involve emitting one or more particles, are photons. Okay, one or more particles are photons. That is radioactive decay. Radioactive decay. Now, what do you see in the picture? Marie Curie. Marie Curie. Then with her husband Pierre Curie. Madam Marie Curie with her husband Pierre Curie. Okay, Pierre Curie. So in 1898, Madam Marie Curie and her husband Pierre Curie found that radioactivity was the property of the elements only. Radioactivity was the property of the elements only and not salts or compounds. Okay, so they found that radioactivity. Madam Marie Curie and her husband Pierre Curie both found the radioactive was the property of the elements only. It is not for salt or compound. It is not salt and also compound. Now, Marie Curie. Already we heard many things about Marie Curie. Yes, Marie Curie. He is a well-known physicist and also chemist. She was the first woman to win a Nobel Prize, and the first great person. She was to be awarded with 2 Nobel Prizes during her lifetime. During her lifetime, she got 2 awarded. She got be awarded with 2 Nobel Prizes. She was a pioneer of radioactivity and discovered 2 elements called polonium and radium. She was a pioneer of radioactivity and she discovered 2 elements. One element name is polonium, another one element name is radium. Okay. She also contributed to the first studies in the treatment of cancer using radioactive isotopes. She also contributed to the first studies in the treatment of cancer. Okay, children. Listen, Madam Marie Curie, she was the scientist. Marie Curie is remembered for her discovery of, still now, Marie Curie is remembered because for her discovery of radium and polonium and her huge contribution to finding treatment for cancer also. For her huge contribution, that is finding treatment for cancer. For cancer, she was finding the treatment. She was finding the treatment for cancer. So she was one of the scientists. Still now, Marie Curie is remembered because she has discovered radium and polonium and her huge contribution to finding treatment for cancer also. Okay. Now, for these 3 purposes, she is remembered still now. For these 3 purposes, she is remembered still now. Okay. Now we are going to study about types of radiation. Okay. Alpha rays, beta rays, gamma rays. Alpha rays, beta rays, gamma rays. Okay. You see, Rutherford. Who is that name? Rutherford. Who is that person? Rutherford studied about radioactive radiation given out by radioactive elements. That all radioactive radiation given out by radioactive elements. Okay. For example, uranium, radium, that elements, radioactive elements. Already we studied what are called radioactive elements. The elements emitting such radiation, that is radioactive elements. For example, uranium and radium. So the radioactive radiation given out by radioactive elements. And he found out 3 kinds of radiation were given out by the nucleus of the radioactive elements. The 3 kinds of radiation. What are the 3 kinds of the radiation? One is alpha rays. Second one, beta rays. Third one, gamma rays. All of you say with me. alpha rays, beta rays and gamma rays. Okay. First of all, we see about alpha rays. Alpha rays, these rays are positively charged. So denoted by the symbol alpha 2, 4. Alpha 2, 4. They have charge is equal to plus 2 units. They have charge is equal to plus 2 units and mass equal to 4 AMU. That means is atomic mass unit. AMU, 4 AMU. At A for atomic, M for mass, U for unit. Okay, children? Okay. So here they have charge equal to plus 2 units and mass equal to 4 AMU. AMU, that full form atomic mass unit. They are similar to helium nuclei. They are similar to helium nuclei, that is represented helium He, the symbol of helium He, helium 2,4. So these rays have less penetrating power. That power is very less. That penetrating power is less and slightly affected by electrical and magnetic field. Slight alpha rays have less penetrating power and also they have slightly affected by electrical and magnetic field. Okay. Then beta rays. You see beta rays. They are negatively charged. So denoted by electron minus 1, 0. They have some charge and mass like that of an electron, Okay. Their penetrating power is greater than alpha rays. Already we studied alpha rays penetrating power is less, but beta rays penetrating power is greater than alpha rays. They are strongly affected by electrical and magnetic field, but alpha rays are slightly affected by electrical and magnetic field, but beta rays are strongly affected by electrical and magnetic field. Then we will study about gamma rays. They are represented by gamma 0, 0. They are neutral particles. They are electromagnetic radiation with high penetrating power compared to alpha rays and beta rays. Okay. They are not affected by electrical and also magnetic field. You see types of radiation: alpha rays, beta rays, gamma rays. Alpha rays high energy because alpha rays protons and neutrons. Beta rays high energy electrons. Then gamma rays high energy radiation. Then X-rays, neutron rays. You see that gamma rays, it likes waves, yes. Beta rays, it likes particles. Paper, alpha rays. Then aluminium, paper, alpha rays. Thin aluminium, beta rays. Thick lead, gamma and X-rays. Then water or concrete stops neutron rays. Okay. Then we will study about uses of radioactive substances. You see here some radioactive isotopes that have medical application. Now isotope and use. Isotope 60CO that use gamma ray irradiation of tumors. gamma ray irradiation of tumor. Then it's 99M TC, brain, thyroid, liver, bone marrow, lung, heart and intestinal scanning, blood volume determination. Okay. Then 131L, diagnosis and treatment of thyroid function. The isotope and their use. We are studying some radioactive isotope and that have medical application. Okay. Then 133XE, lung imaging. It is used for lung imaging. Uses of radioactive substances. You look at your book, page number 36. Radioactive materials like carbon-14 are used to determine the age of rock, minerals, fossils and dead organisms. So this is done using carbon dating technique. Carbon dating technique. Radioactive material like carbon-14. This carbon-14 radioactive substance used to determine the age of rocks, minerals, fossils, dead organisms. So this is done using carbon dating techniques. Okay, children. Then gamma radiation are used to sterilize the food. உணவுகளை பதப்படுத்துவதற்கு பயன்படுகிறது. And also உணவுகளை பாதுகாப்பதற்கும் பயன்படுத்தப்படுகிறது. சரியா? Are used to sterilize food and are also used to preserve food. Then radioactive substances are used to study the mechanism of chemical reaction. Are used to study the mechanism of chemical reaction. Then it is used to check cracks in pipelines. Suppose some cracks on pipelines or machines. So these substances, radioactive substances, are used to check whether it is cracked or not. Okay, for checking purpose. Then they find wide use in medicinal field to cure many diseases. Wide use in medicinal field because it cures many diseases. Radioactive substance. For example, cobalt-60 used in cancer treatment. Then sodium-24 controls the blood circulation. Phosphorus isotope is used to study the absorption rate of plants. Then cobalt, sodium isotope, phosphorus isotope, then iodine 131 is used to treat thyroid deficiencies. Then uranium isotope 235 used to peaceful purposes like generation of electricity in power plants by fission reaction. Okay, so many uses. So that these are uses of radioactive substances. Okay, children. Harmful effects of radioactive substances. So harmful, தீமை விளைவிக்கக்கூடிய harmful effects of radioactive substances. Listen here. Radioactive sources. Radioactive substances are used in so many ways. Some ways. We will see that are used to study living organisms, to diagnose and to treat diseases, to sterilize medical instrument and food, to produce energy for heat and electric power, and to monitor various steps in all types of industrial processes. Traces are a common application of radioisotopes. Okay, so radioactive sources, the uses of radioactive substances, helping in our life, Okay, next. Now we are studying about harmful effects of radioactive substances. You look at your book, page number 536. Harmful effects of radioactive substances. All radioactive radiation can penetrate into living and non-living matter. They can penetrate. They can penetrate. They can go into living and non-living matter. They change the cell structure. First of all, they change the cell structure, leading to gene mutation. For example, mutation மாற்றங்களை கொண்டு வருவது. சரியா? Abnormal changes are produced in living organism in their basic genes. That is abnormal changes. Abnormal changes are produced in living organism. in their basic gene. Okay, that's why they change the cell structure. Change the cell structure. Then they lead to skin cancer and other forms of cancer also. Then they lead to deformed babies with defects. குறைபாடுடைய குழந்தைகள். They lead to deformed babies with defects. Then they lead to reduction in immunity. Reduction in immunity. நோய் எதிர்ப்பு சக்தியை குறைக்கிறது. They lead to reduction in immunity. Then loss of hair and internal bleeding occurs when exposed to excess radiation. It may lead to death also. Loss of hair and internal bleeding occurs when exposed to excess radiation. Okay children, even it leads to death also. Here you look at this PPT. Exposure to very high levels of radiation, such as being close to an atomic blast, they can cause acute health effects such as skin burns and acute radiation syndrome, that is radiation sickness. It can also result in long-term health effects such as cancer, cardiovascular disease. So you take any one thing, many useful things also there and many harmful things also there. Yes. So the harmful effects of radioactive substances, when we are learning, it is very risk for us. Yes, because it leads to skin cancer and also other forms of cancer, and also even leads to death. Now, radioactivity can cause nausea, vomiting, hair loss, diarrhea, hemorrhage, destruction of the intestinal lining, central nervous system damage, and also death. It also causes DNA damage and raises the risk of cancer, particularly in young children and fetuses. Okay children, so they are harmful effects of radioactivity. Okay children, all of you take your book, nuclear energy. You take nuclear energy. Chemical reactions are accompanied by loss or gain of electron or sharing of electrons. Already you have studied in the previous class. If any one element loss an electron, that is positively charged ion, that is cation, we studied. Yes. So it may be losing or gain or sharing of electrons. Loss or gain of protons or neutrons present in nucleus. Listen, protons and neutrons, they present in the nucleus. So loss or gain of protons or neutrons present in the nucleus, that results in nuclear reactions. So the energy stored in the nucleus of the atom during nuclear reaction, that is called nuclear energy. Already we know protons and neutrons are present in the nucleus of the atom. So the energy stored in the nucleus of the atom during the nuclear reaction, that is called nuclear energy. Okay, nuclear energy. You see, nuclear energy also called atomic energy. Nuclear energy is also called atomic energy. The energy that is released in significant amounts in processes that affect atomic nuclei, the dense cores of atoms. It is distinct from the energy of the other atomic phenomena, such as ordinary chemical reactions, which involve only the orbital electrons of atom. That orbits, it has electrons. Yes, listen, the orbits for k orbit or shell, L orbits or shell, M orbits or shell, N orbits or shell. We studied in that previous classes. So it is distinct from the energy of other atomic phenomena, such as ordinary chemical reactions that involve only the orbital electrons of atoms. Okay, then the nuclear energy can be produced by two types. two types of reaction. One reaction name is nuclear fission, another one is nuclear fusion. Nuclear fission, another one nuclear fusion. Okay, look at this picture, children. What do you see? Nuclear fission chain reaction. Nuclear fission chain reaction. You see here, neutron, uranium 235 nucleus splitting, then energy release, fission products, energy release, fission products, that neutron, uranium 235 nucleus. This is chain reaction. Okay, nuclear fission chain reaction. Listen, breaking of a nucleus of the large atom into that the nucleus of the large atom is breaking into two or more smaller atom with releasing energy, with a large amount of energy is releasing. That is called nuclear fission. Okay, the fission can happen naturally. It may be happened naturally, or it is happening by bombarding an atom with fast moving neutron. For example, when an isotope of uranium, you see, when an isotope of uranium 235 92 235 is bombarded with a neutron, it forms an unstable radioactive isotope. You look at page number 37, children. Uranium bombarded with neutron, so it forms unstable uranium radioactive isotope. Within the bracket, uranium 92 236. Okay, then this breaks into two smaller nuclei, that is barium and krypton. It breaks into two smaller nuclei, barium and krypton, which are stable along with the three free neutrons, okay, and release a large amount of energy also. You look at that formula. The three neutrons formed react with uranium 92 235 atom and continue the fission. This chain reaction continues at a faster rate with the release of tremendous amount of energy. The tremendous amount of energy is used under controlled conditions to produce steam, which allow turbine to produce electricity. So this principle is used in nuclear power plants. Okay, you see here that fissionable nucleus, incident neutron, then uranium 235 nucleus, that is the fissionable nucleus, splitting of nucleus, they are releasing energy release. Then incident neutron, they are incident neutron. Then they are chain reaction, uranium 235 nucleus, they are chain reaction. Okay, children. Then now look at this. What do you see in the picture? This is sun. This is an example of nuclear fusion. Okay, this is an example of nuclear fusion, because nuclear fusion reactions are responsible for energy of stars. Okay, that's why one example, that is sun. Listen, nuclear reaction. In this reaction, that lighter nuclei join together, then they give heavier nucleus. Then they give heavier nucleus, releasing large amount of energy. Releasing large amount of energy. That is nuclear fusion. Okay, children. How nuclear fusion takes place? How nuclear fusion takes place? That takes place at very, very high temperature and also pressure. But they are releasing energy. That energy cannot be used for generating current. That energy cannot be used for generating current. Okay, children? Listen, children. Listen. This is nuclear power plant. Nuclear power plant. Okay. Uses of nuclear energy. This plant based on uses of nuclear energy. As seen in nuclear fission, listen, the nuclear fission, the tremendous amount of energy released. Yes, that is used to produce the electricity. மின்சாரம் தயாரிப்பதற்கு பயன்படுகிறது. So the energy used to produce electricity. In nuclear power plant, அணு மின் நிலையத்திலிருந்து மின்சாரங்கள் தயாரிக்கப்படுகிறது. Yes, அணு மின் நிலையங்களிலிருந்து தயாரிக்கப்படுகிற மின்சாரங்கள். So the nuclear fission, the tremendous amount of energy released, that energy is used to produce the electricity in this plant, in this nuclear power plant. Okay, you see here it is in Kudangulam. Yes, Kudangulam அணு மின் நிலையம். You see that we can see nuclear power plant at Kudangulam. We can see the nuclear power plant at Kudangulam. Look at this. This is nuclear reactor. That nuclear power plant. Okay, nuclear reactor. You look at that picture. Containment structure. Reactor, pressure vessel, then pump, then 283 degrees Celsius, 7 MPa steam, turbine is there, generator is there, cooling water, condenser, then that cooling tower, air 25 degrees, air goes in 35 degrees Celsius, then comes out 25 degrees Celsius. Nuclear reactor. Okay, it works on this nuclear power plant works on nuclear fission principle. Okay, a nuclear reactor is made up of a reactor in which nuclear fission takes place, a turbine and a generator. Generator helps in converting the one form of energy to another form. Converting one form of energy to another form. Okay, converting one form of energy to another form. That is nuclear energy convert into mechanical energy, then into electrical energy. So that converting one form of energy to another form of energy. In India, where it is located at Tarapur, Kota, Kalpakkam, Nararo, Rana Pratap Sagar. These places in this nuclear power plant are located at these all places. Okay, nuclear reactor. You see that pressurizer, control rods, a reactor vessel, steam generator, then generator, turbine, condenser, all those is here. Nuclear reactor. Okay, children. Then we will study about safety requirements at nuclear power plants. All of you take your book. Page number 37, safety requirements at nuclear power plants. Nuclear power plants involve nuclear reactions giving out plenty of hazardous radiation. Hazardous na தீமை விளைவிக்கக்கூடிய கதிர்களை அதிகமாக வெளியிடுகிறது. Giving out plenty of hazardous radiation. Safety measurement should be given top priority. Safety measurement should be given top priority. Some following or some of the precaution and safety requirement. Here some parts are given, some points are given, that all the points are based on precaution and also safety requirements. Okay, how the workers should be there, what should they wear, how should they wear, that all given here. Workers must be wearing special aprons and gloves made up of lead, and also eyes should be protected by using special eye glasses. Special eye glasses. Then nuclear power plants should be checked periodically to ensure that is there any leak. So when we are checking periodically, the leak should be proved, yes or no. Then the enclosure of nuclear reactor should be made up of material but doesn't allow radiation to be leaked out. Doesn't allow the radiation to be leaked out. Nuclear waste should be handled and disposed of with utmost care. So nuclear reactors should be planted away from dwelling areas and from populated area. Should be planted away. அணுமின் நிலையங்கள், இது போன்ற நிலையங்கள், மின் நிலையங்கள் மக்கள் வசிக்கிற இடத்துல இருந்து கொஞ்சம் தூரத்தில் என்ன செய்யணும், இருக்கிறத நம்ம என்ன செய்யணும், திட்டம் போடணும். Nuclear reactors should be planted away from dwelling areas and from populated area. Okay, you look at this. What is the safety nuclear reactor design? SMRS, or a slimmed down version of conventional fission reactor. Although they produce far less power, their smaller size and use of the shelf components help reduce cost. These reactors are designed to be safer than traditional water-cooled reactor, using coolants such as liquid sodium or molten salts instead. Listen, SMRS, that is a slimmed down version of conventional fission reactor. They produce far less power, their smaller size and use up of the shelf components, they help reduce the cost. Okay, then these reactors are designed to be safer than traditional water cooled reactor, using coolants that is such as liquid sodium or molten salts instead of that. Okay children, now homework. All of you take a homework note, write a homework question. First question, write notes on nuclear power plant. Write notes on nuclear power plant. Second, write the postulates of Boyers-Autumn model. Write the postulates of Boyers-Autumn model. Okay, only 2 questions. Write this question fast and write the answer fast. Then take photo and send the homework in our school WhatsApp. Okay children, we will meet again in the next video. Thank you all.